Well, thank you everybody for being here. I wasn't expecting this crowd this late this late in the day. So today I'm going to be talking about regex strike back, or how to do text mining with regular expressions. But before, a little bit about me. Well, you already know my name, Daniel. I'm originally from Cuba, but currently I'm based on Barcelona. In the past, I've been a research engineer in universities, data scientist, and a startup. When I'm not working, you can find me on Stack Overflow, helping people out by answering their questions, but mostly learning from the community. Currently, I work as a software engineer, doing Java most of the time, so not so fun, at Trie now. That is a super mobility app that is currently based on several countries in Europe, like Germany, Spain, and France. Nevertheless, Trie now is an excellent employer, and we do have very interesting openings in the data space, so please feel free to check them out. What I'm not, despite the title of the talk, I don't consider myself a regular expression expert, so no, I won't be coming swinging on a rope to say the day and type some regular expression that will solve everything magically. Actually, on the contrary, in this talk, I want to show you that with very simple regular expressions, you can achieve a lot, at least for text mining. Okay, so for the remainder of the talk, probably you are going to learn some basic text mining, and together with some Python tips, but mostly you will learn about how to make regular expressions, at least a particular subset of regular expressions, go fast. What do I mean by text mining? Text mining is basically the process of transforming unstructured or free text into data. Data can be from a known set of keywords to a vector encoding. So this text is going to be filtered to a known set of keywords or transformed into a vector. One branch of text mining focuses on using ontologies, vocabularies, and custom dictionary from transforming this free text into data. So basically, the process reduces to a keyword search for filtering, cleaning, and encoding. Why regular expressions? Probably if you ask around, regular expressions have a bad reputation. You probably have seen this quote that some people, when confronted with a problem, think, I know, I use regular expressions. Now they have two problems. This is not entirely true, and one of the reasons you might consider using regular expressions is because they are very powerful in regards with the expression power that they have. They are ubiquitous in the sense that you can find them in any language, in any programming language, Python, Java, PHP, whatever. And not only in programming language, but in any applications. You will see like many libraries do provide support for using regular expressions on them. And sometimes, if properly tuned, they can be fast. And this is what we're going to talk here. So first, let's do a quick regular expression 101. The regular expression module in Python is the RE module. So if you want to search for a word or a pattern in particular, you can use re.search. You pass the pattern that you want to find, and it will look for the first location where the regular expression pattern, in this case pepper, produces a match and will return a corresponding match object. So the sky is blue and the pepper is yellow. It returns a match object. Basically, it has the chunk of text that was matched together with some extra info that is the start and the end of the match. If you want to search for one or more keywords, what you can do is use the OR operator or the PY operator. Basically, pepper, you can read it as pepper or sky, and it will return again the first match, in this case, the sky. Why is this useful? You can use this, for example, to filter a set of strings where you only want to keep those that contains a set of keywords, like in the example. If you want to find all non-overlapping matches of the pattern in a string, you can use find all, and it will return these occurrences as a list of strings. The string is scanned from left to right, and the matches are returned in the order they appear. For example, here pepper sky, the first string is sky, and the second string is pepper. What can you use this for? You can use this for one-hot encoding. Basically, one-hot encoding transforms a text into a vector where it has a 1 if the word is present, or it's 0 otherwise. There is an alternative to find all, and it's find iter. Basically, it returns, as the name suggests, an iterator yielding match objects of or not overlapping matches for the regular expression pattern. Again, the string is scanned from left to right, and the matches are returned in the order of this. Here, we're transforming the iterator to a list. Okay. So, how is this useful, and how you can use it besides find all? You can use it to add like metadata to the matches. For example, if you want to, together with the text or the chunk of text match, you want to return the start and the end position, you can do it as in the string. You basically do like a list comprehension, and you access the start function, the start method, the end method, and the group method for each match. Another interesting function in the RE module is sub. Basically, it will return the string obtained by replacing the leftmost non-overlapping occurrence of pattern in a string by the REPL argument. The REPL argument in this case is object, and the string, if the pattern is not found, the string is returned unmatched. For example, here we found pepper and sky, and we replace them by object, and you can see that the result is the object is blue and the object is yellow. Both pepper and sky were replaced. And now, some unknown feature is that REPL can be also a function. It's not only like a string. So you can use this property of the sub function in conjunction with the dictionary to replace for each word a particular example. For example, here lookup, in lookup we have a dictionary that will map pepper to pimiento, is the Spanish translation of pepper, sky to cielo, again the Spanish translation, and it will replace each of the match by the corresponding value in the dictionary. The cielo is blue and the pimiento is yellow. This is very useful for text mining, for cleaning. For example, you can replace all the punctuation symbols by space to clean text, or you can replace all different spellings of a word by a normalized one. Finally, all these methods that we have seen before, they receive an optional parameter that is a flag. In this case, this flag is the ignore case, and it's basically telling the method that it should match regardless of the case. So here, pepper is all uppercase, and we can see that it matches. So far, all we have seen in the RE module are functions that are based on the exact match. But if we go a bit further and use a third-party module like Regex, you can do like a fuzzy match. How it works? Here we have a pattern that is basically saying I want to match any of the words monkey, monster, dog, and cat with at least one error and at most two errors. So the notation between braces, that is what it's telling. And we pass that pattern to the search, and for example, with the string, this is really a master DAG, and we use the flag regex best match, and it will return the best match that is basically DAG. Why DAG? Because you can obtain, of course, a dog by replacing the A by an O. And here it have this object has an additional parameter that is fuzzy counts. Basically, what it's telling is the number of replacement, deletion, and insertion that you need to do from the match to obtain one of the one of the words in the pattern. As you have my guess, this is very useful for doing fuzzy matching. So what's the problem then? We have seen that so far with very simple notation and a very small set of functions, we can do many of the things that you can find in text mining. So basically, the problem, as you can read in this tweet, is that the pattern that we have been seeing, the OR pipe, is very slow. In this example, a guy was trying to run with a very large number of keywords, and according to him, the regular expression was taking almost 5 days. So, you can see here that this is basically a toy example for a pattern of 1,000 words and a text of 10,000 words. It was taking 110 milliseconds. That may not seem much, but if you have to do it repeatedly, it will add up. Why does this happen? To understand why does this happen, we have to take a look at the Regex engine under the hood, and also to gather some tips on how can we craft a better regular expression. For taking a look under the hood, we can use the compile function of the RE module together with the debug flag. This is a partial output of what this is going to show you in the console. Basically, what it's telling you it's going to try first the pepper, one character at the time, or sky, one character at the time. When the keywords doesn't have like a common prefix, this is optimal. But what happens when you have like common prefix, like in this example of baby and bat, you will see that the Regex engine does an optimization. It pull out the common prefixes from the keywords, and it put it outside of the branch. For instance, he will try to match B or A first, and if it doesn't match, it will fail. And then he will try to match either B, Y, or T. Again, what's the problem with this? As this code is taken from the RE module itself, it will only do that if all the keywords share a common prefix. So for instance, if you have baby, bat, and monkey, it won't do that. It won't do the optimization for baby and bat. So for making regular expressions great again, I wrote a small library called Trie Regex. Trie Regex stands for Trie plus Regex. It can be pip installed. Basically, what it does, it takes a list of strings, it transforms it into a trie. For those of you who don't know what a trie is you can think of another name is a prefix tree, and basically all the words that share a common prefix will be in the same branch. For example, bank, bat, and baby are all in the same branch, and air is in another branch. It branches out with the unique suffixes. Once we have this trie, we can transform it into this regular expression. Basically, it's an optimized regular expression that does like a generalization on what the Regex engine is trying to do. How you can use it, basically you import Trie Regex TX, and it has only one function. It's very easy to use. You pass the list of words. You pass a prefix, so something that you want to put before all the words, and a suffix, something that you want to put behind all the words, and you can produce a pattern. Here you can see that monster and monkey were put in one branch, and baby and bat were put in another branch. How fast is it? Union Regex is what we have been seeing at the beginning. Basically, all the words joined together by the pipe operator. And Trie Regex is a pattern obtained with Trie Regex. you can see that for 20,000 keywords, Trie Regex was 250 times faster than Union Regex. To finish, I want to talk about one other really good aspect of regular expression, that they are ubiquitous, so you can find them. You can find many tools that integrate with them, and one tool that is very used in the data space is Pandas. So here you have a data frame that consists of a single column, that each cell of the column is a string. You can make a pattern with Trie Regex, and you can use the str accessor to access different functions for strings. In this case, contains will return true if the pattern was found, false if the pattern was not found. Additionally, Pandas has a lot of functions that mirror the functionality that you could find in the RE module. Basically, search will match to contains or struct in Pandas, find all will match to find all or struct all, and sub is called replace in Pandas. If you want to learn more about this, you can find more information in the Trie Regex repo. Also, there is this tool called flash text that is an alternative that doesn't use regular expressions. That is also very useful. In this particular stack, answer of Stack Overflow, they have like another benchmark and another way of building an optimized regular expression for doing keyword search. That's it. Thank you for your time.
Daniel, that was a very insightful presentation. So currently, there is no question on Slido. So if anybody has a question, feel free to raise your hand. All right, great. Let's take that.
May I? Thank you very much for your presentation and making us find out about this library. I think it's really useful. So my question to you is, can your Python library generate a pattern also with the option of fuzzy matching?
Yes.
It can?
Yes.
Okay.
Basically, if you... Let me go back. If you see here, you have a prefix and a suffix. So you basically, what you do, if you set the prefix to the notation that you saw in between the brackets, and that's it.
Ah, that's all. Ah,
yeah.
That's really great. Thank you.
All right. Is there any other question? Okay. In the absence of any other question, I guess we can wrap this up. Thank you so much, Daniel, for the presentation.